Alright, I've got a Zenith solid state 23 inch, I'm sorry, 25 inch color TV, 25 DC 56C, I believe is the model number, that had a focus issue. And the focus issue was that when I would adjust the focus pot, this thing right here, which was on the back panel of it, the focus would get sharper, but only at the most extreme end, and you could never tell if you were getting as focused as possible because it would never go in and out of focus. It would just get more focus at the extreme end. In this particular case, it was the extreme end where the voltage setting was at the focus voltage was setting was at the lowest. That would be fully counterclockwise here. Now, I checked the voltage with a high voltage probe to see which way it was going, just to confirm that. So once I decided I was having a focus voltage problem, there really isn't too much to go wrong with this particular set, except that resistor, which goes to the ground. This lead goes to the ground, 4.7 meg. This is a well, it says it's a 15 meg in the schematic, and it doesn't say anything on the pot. I don't see it, although it tests 30 meg, and it has this voltage divider. Now the voltage divider takes this goes to the high voltage lead, so this goes to 25 kV. This lead goes to the focus pin of the CRT, and this continues the focus voltage division down to the center lead of this pot and into the ground. So basically you go from 25K through the white wire, through the pot, through the resistor to the ground, with this black lead being the tap somewhere in the middle of that chain to pick off the focus voltage. So it's not too, like I said, there's only really three parts of this that can go wrong. Well, I tested that resistor, and indeed it had drifted high. Let me see if I can get a quick test on that. I've got my analog probe hooked up right now. So what I'll do is I'll just check this resistor first. And let's see what I get. I'm at the 1 meg reading, and that's reading about 5, 6, 7. That's about 7.5 megs. That's a 5 division, and I think you can just barely focus on it. This thing's been giving me real problems auto-focusing lately. So, alright, resistor's high. But frankly, we're talking about a total chain here of like in the hundreds of meg, so that's really not going to be the problem. But I'll replace it anyway, because what the heck. Next thing we can check is the pot itself. Again, the pot itself can't be that much of a problem. I mean, unless it's nearly open, because I already have it fully closed, which means the total resistance of the pot is irrelevant as long as it's essentially shorting when it's closed out. You can, I mean, that's just the way it is. Unless it goes wide open immediately, it should still work. I mean, I should still be able to focus if I turn fully counterclockwise. Now let's see where we are with this pot. I've got it currently connected up. One leg here, center lead there. Yeah, okay. So let me just what the pot's reading. Well, right now I've got the pot. It's sitting at about. It's gonna be hard for me to. I'll just tell you what that says. That's at about 17 mega ohms. So I don't know where the position of this pot's set. Let me fully close it first. All right, there it's fully closed. So again, essentially the pot is out of the circuit, so that doesn't really make any sense that the pot could be causing the lack of focus issue. Minimum resistance, I mean, that's at 1K. That's about, well, here we go. There. It's 500 ohms, alright? So fully closed is 500 ohms. The 100 ohm is on number 5. So let's see what the max resistance is. Almost 30 meg. Now, like I said, the schematic says 15 meg on this thing, but that could have been a production change. It seems odd that's almost exactly 30. I guess it could have gone high. I don't know if this is a wire wound or what kind of compositions made, but besides the fact that I've got a resistance here, I don't really think this is the problem. Here's the other thing I noticed. If you see, I'll adjust it. I'm turning the pot slowly. Good. I'm getting a nice analog linear type. Oh, oh, whoa. Okay, so what happened there is I was slowly turning the pot, and all of a sudden it went wide open. I'm going to turn another notch here. Boom, back. That's not what you want. This is why you really need to use analog meters, by the way, when you're checking the action of a pot. I mean, you can check the total resistance if you want, but to really see how is a pot going to function in a circuit, digital meters don't really do good on indications this way. You just can't see this kind of response as easily. At least I don't think so. But anyway, he's got that big swing, doesn't make any sense. And then he continues. Well, that was me just turning it real fast. Whoa. And it's repeatable. It's not just a fluke here. I found, boom, there it goes again. It's exactly the same spot. Now, you know, in the interest of science, I'm considered opening this pot. I'm trying to figure out why that is, because you say, oh, well, David, there's a dead zone. No, there's not a dead zone because I'm in an open pot somewhere. If I do this, and the pot gives you the 30 meg. So clearly there's continuity here, and if I move the wiper, sometimes if you have an open pot, open section in a pot, like if there's a crack in the resistance material, you know, it'll read wide open until you hit a particular spot. This one I'm moving the pot and there's no effect, so the wiper doesn't have any effect on the total continuity. So it's as if there's a spot on the resistance element that when the wiper comes around and touches it, it's insulated and it opens up for a fraction, you know, for that little tiny bit, that exact same spot. Then once you move past it, boom, it's right back on it again. I'm thinking maybe that's where the pot wiper had set for a particularly long time, and maybe if it's a wire wound, maybe there's a little depression there and it comes off, the wiper doesn't press down. I don't know what's going on. That's why I'm saying in the interest of science, I may opt to open this up. But again, I don't think the pot is the reason it's not focusing. What what you're seeing there, what I would expect is, okay, if I was to adjust the pot across the whole spectrum, and while attempting to focus it, there would be one spot in the focus where all of a sudden, boom, the focus would go out. But it'd be a very, very narrow spot, only one tiny little area where that happens, and then it immediately go right back into focus. And that's not the symptom I'm getting here. I'm getting a constant smooth focus, and then almost sharp, but never unfocused again. So again, I don't think this is the problem. It's doing what it's supposed to essentially, and that it's giving me an analog response as I adjust it, except for that one particular spot. Which leads me to the only other little offender that would be this thing here. This thing's hard to test. I mean, this is like a 600-700 mega ohm thing. I'll see if I can get a response on it. Alright, the top of the chain would be up here at the anode, and the bottom would be this white lead. And I'm getting, wow, let me see if I can see any movement at all there. I'm going to disconnect it and reconnect it. See if I can really see something here. Okay. Okay, you can see there was some movement there. I've got this thing. Let me null this thing out. Okay, I'm right at 1. I'm right on the infinity reading. I'm going to hook it up again. Sorry for the bad camera work. Okay, it's definitely, you know, getting a reading. Not much of a change, but it definitely moved, which I would expect. Again, it's a very, I mean, this thing's only in a 1 meg denomination, so I'm talking hundreds of meg here. Now, for fun, I'm going to get off the remember, that's the big division right here. That's from the anode to the focus pin. I'm to the end of the chain. This time I'm going to see if I can go just from the from the end of the divider to the focus lead, which should be considerably lower resistance. So that would be from the white lead, which is basically the bottom, to the, if I can get on that. There we go. Okay. So I'm at about, let's see, 50, 60, 70 meg there, which I believe is what they call for in the schematic of the set. Again, these things are kind of, that was supposed to be a 15 and is a 30, so you know, I'm not exactly sure how accurate maybe some of the resistance readings are in the set versus what I'm getting here. But clearly the voltage divider is obviously working. It's just not working right. So what I did was I bought a one of these. Went down to the local Radio Shack and picked up a voltage divider, and that was the part number that was called out in the schematic. And when I did the same test, that dropped down closer to 50, where it's currently reading about, well, almost 80 meg now. So I replaced this part, that pot, and the new resistor, and I've got it all installed in the set. So I'm going to I'll be going over there in a minute and showing the rest of this video with these parts replaced. I might end up taking this thing, like I said, taking this part, and if I can get that one spot worked out, I wouldn't hesitate to reuse this pot, only because I like the way it terminates with this adjustment. On the one I had to replace it with, you have to have just a plastic screwdriver go inside there. It's still a high voltage pot because it has all this nice plastic stuff here and snaps into the chassis. So that part of the replacement pot is correct. But what's not correct is the replacement pot had the kind where this is recessed and you have to use an insulated tool to get in there if you're smart, an insulated tool to get in there and adjust it to adjust the focus. I really like this pot better. And again, the difference between the 50 meg and the 30 meg is really irrelevant because you're adjusting, here with this center leg, it just gives you more range really. And considering the total megage of all this stuff, total resistance of all this, that's really not a significant factor. So, like I said, I'm going to see if I can't resolve this issue while I'm at it. More later. Thanks for watching. Okay. Here's the pot that's been pulled apart. See those two little dots? Right here. Let me go on the angle so you can see it. Right there, right? I can't drive in picture. Here we got one there, those two little dots. Okay, those seem to correlate to the little pickup parts right here. And my guess is that they're tiny little depressions where this thing must have sat for a long time at some point in its life and just conducted a lot of current, kind of dug a little divots, but not enough to break through the element, because you can see there's still resistance around it. So I don't know if this is salvageable. I was thinking maybe I could put a tiny little bit of conductive paint on those, or just maybe just try to smooth out those that little wiper. But I'm sure that's what's going on. That's when it hits that is where it gets out of whack. Anyway, I'm going to play around with this a little bit. So like I said, I really like this pot. I don't know how easy it would be for me to swap elements. I guess I could keep the I don't know if I could swap these elements with the new type of, it's a completely different kind of pot. I mean, like I said, it's still a high voltage with this front piece insulating everything and for installing it and all, but this is very different on the replacement pot. So I don't know if I could very easily swap those guts, which is what I've done sometimes. When I've tried to keep the form of the pot the same, you just take this part out and substitute it in the new pot to the old pot's hardware, and you're good to go. But I'm sure that's what's happening when I'm hitting those spots, is where I'm losing the contact. More later. Okay, here's the new pot that's been installed. You see what I'm talking about? Here's this inside the chassis. This actually comes out this way, and then you have to end up going out here and adjusting it. It's just the design of the pot was made that way. Not very much I can do about that.
I got the new 4.7 meg installed there. I just pigtailed that on to the end of the old lead from the original pot. Sometimes those solder pots that Zenith has, especially if you're on the ground lug, can be really hard to unsolder. I didn't want to force the issue there, so I just took the better part of an hour and just pigtailed and slid it over and soldered it up. I've got the new pot installed, and it's just really just a variable resistor here. As you can see, one lead is not used. So I've got this goes back to that focus to that voltage divider. This goes the other side of the pot to the ground. This white lead here comes up and fishes through a hole in the bottom of the chassis and pokes right up through there, which you can't see. I'll go to the top. I was able to do this without pulling the chassis, which is always a good thing. Let me get my flashlight on there a little better. So here's the new voltage divider installed. That white lead goes through a hole down through the pot. That black lead fishes up underneath this white board here. God, this is really hard to see. I don't know how much is I'm getting. See if I can get this. There it is. There's the black lead. I tried to duplicate the lead dress. There it is. You can see it right there. It goes through this board. There's the other side of it. And there you can see pretty well. Well, that's not black lead there. It gets kind of confusing. There you go. You see, kind of coming out and wrapping around. So it just goes to this board. This fiber board is for lead dress. Hooks up here, which goes to the focus pin. Okay, so there's a focus pin lead. The red lead comes out of that, goes through this little dress cardboard device, comes up and hooks up to the high voltage anode. That's a real easy deal there. You just unscrew a little Phillips screw in the middle of this thing on the underside of that suction cup, and the leads just pull out, and they're retained mechanically with that Phillips, which is kind of cool. So one side, so clearly there's two leads. One's to high voltage, goes right to the tripler, which is right there, and the other side goes back to my voltage divider. So this is all set up and good to go. So I'll button this all up and show you the picture of it working. But like I said, the only real downside to all this is right here. Used to be I had a nice little extension that came out of here, and I could adjust it from the back. Now I've got to reach in there with a screwdriver like this to adjust it, which is, well, it's unfortunate, but just the way it is. But it does work, so that's better. I really wish I could make that other thing work. I want to take one more look at this, see how this thing's configured. There's a real good chance that I could use the resistance element here and keep the original mechanicals of that pot. I'm kind of torn beside wanting to do that as opposed to just leaving well enough alone. I don't know. I'll think about it. I'll probably keep the old pot in a plastic bag just hanging inside the TV somewhere, and if I ever get motivated or whatever, decide I want to address that, I will. Anyway, more later. Thanks for watching. Okay, and we got it all back together now. Focus is nice and crisp, and it's not at the extreme end of the range.
By 1914,
just for fun, I went ahead and let me turn this down.
The Ford Motor Company.
For fun, I went ahead and put the original pot back in. I figured that one tiny little dead zone is not going to be a big deal. I mean, first of all, it's unlikely it'll focus exactly there, and second of all, even if it did, you go either side of it a hair and it's right back on again. So it was literally just one tiny spot where it was not perfect.
and I decided that I preferred the way the pot shaft was accessible without having to use a screwdriver. Made that worth it. Not to mention, I don't know. I just really don't like replacing parts that don't need to be replaced on vintage TVs. This TV is about as original as it can be. The only parts that have been replaced that I could even pick up on were the original safety caps in the high voltage circuit, which is a well-known defect and a recall item actually for Zenith back in the day. And that was done, you know, with the correct safety caps back in the day. I mean, there might have been electrolytics replaced in there somewhere. I don't know. I don't recall replacing myself. It certainly wasn't any wholesale cap replacements. And there's just something to me about how these things seem to just keep running. I mean, they arguably one of the best TV chassis ever built. Built like a tank. CRT is great. I mean, it absolutely is perfect. So it's original Zenith CRT. So anyway, in the sake of originality, I used a Zenith voltage divider replacement, and I was able to leave the pot alone. If I ever happen to come across the correct pot, I'll go ahead and keep it. Look at that color. Look at that thing pop. Anyway, if I ever come across the correct pot, I'll go ahead and put it in. Anyway, that's all for this series of Zenith videos. Thanks again for watching.